We are going to talk about netcat today. It was written by a hobbit. Imagine someone like Frodo, but because Frodo would have grown since 1996, he might look something like this. If you go around and ask the community of hackers, they will all vouch for the awesomeness and usefulness of this cat here. And by cat, I mean this tool, which has many tricks up its sleeves, and because of that, it is also called the Swiss Army knife of hackers. It can take connections from anywhere. It can also form connections to anywhere. It lets you choose if you want to use TCP or if you want to use UDP. It can help look up the IP address. It can use any source port and any source address. It can scan your network, can help you pick routes to test the network. All in all, it can do so many things like a ninja tool that most organizations remove this application from their environments to not deal with any hassles later. So, a handy tool like that may not be at our constant disposal, but what we might have with us is Python. We can create our own netcat using Python. It obviously won't be as extensive as the real tool, but it can get some simple things done. I have decided to call mine the SneakyCat. Think about the simple things we need to do with netcat. For starters, I mostly use it to get reverse shells and run commands. So let's try to implement that logic. To replicate the essential functionalities of netcat, particularly for obtaining reverse shells and executing commands, we will need a method to handle command line arguments in our Python script. For this purpose, there are several libraries available, but the most commonly used are argparse and getopt. While getopt offers a traditional approach with a syntax similar to C, argparse tends to be the preferred choice due to its versatility and user-friendly features. Therefore, we will begin by importing argparse. We also import textwrap as it usually works hand in hand with argparse and is mostly used to parse input commands and display outputs neatly. We use the argparse to define what type of command line arguments are we expecting. Here we have four simple functionalities that we usually use in netcat to form reverse shells. We have one option for a command shell, then one for listening, and the two important ones that tell us where we should be connecting, namely the target and the port. We begin by creating a class named SneakyCat, which serves as the foundational blueprint for the functionalities we aim to achieve with the help of our tool. The initialization method, or the constructor as it's known in so many programming languages, sets the stage for when the tool is executed. Initially, the data buffer is empty, reflecting the absence of data. However, as we start the data transmission, this buffer will be populated accordingly. Once we are done with the initialization, our focus shifts to defining methods that will be employed based on our arguments. Specifically, we need to delve into two critical functionalities, the listen and the command. The listen method will monitor any incoming network connections. The command method encapsulates the logic necessary for handling commands received over the network, effectively simulating the shell logic essential for command execution. To handle any network connections, we need to work with sockets. We can do this by importing the socket library. Given our focus is on IPv4 addresses, we select the AF INET as our option. For the type, we opt for sock stream because we want to utilize the TCP connections. And they will be reliable and connection oriented, unlike the UDP datagrams. We also set a few socket options that help us restart a connection quickly to the same port or dealing with abrupt termination of a service. This is typical network programming that we usually use all these options. Now that we have the boilerplate of our tool, let's get back to the main function, starting with parsing arguments obtained from the user. Fundamentally have two options. We are either listening or we are not. Listen will mostly be used on the server-side connections or to devices that we are trying to connect to run commands. Here, the buffer will have no data initially as it is waiting for incoming data and hence will be an empty string. For client-side connections, we will get data from our standard input and we will try to read that and that will be stored in our buffer data. We then create an object for the class. We also instantiate it with two arguments. We need the arguments that we got from the user, and then we encode it with the buffer data. As we haven't specified any encoding techniques in Python, it will use the UTF encoding scheme, pretty standard, and then we invoke the run method. We have to define it in our class and then provide the logic. In our scenario, the base case is pretty simple. We are either listening or we are sending data. And so we invoke two methods, listen and send. For the listen method, we bind to a network interface and a port. By default, this will be the local host of any system. We then specify the maximum number of queued connections that this method can handle. We then keep listening until we receive an interruption. We achieve this by using a while true infinite loop. This is a common pattern for a network server that continuously waits for and then accepts incoming connections. So for each connection, the server can then use the returned client socket to communicate with the client. The infinite loop ensures that the server does not stop after handling a single connection, but instead goes back to waiting for more connections. Now, to implement the concurrent connections, we have to use the Python's inbuilt library, which we use often, I hope, in our code generally, and it's called threading. This will allow us to form multiple simultaneous connections. We just start with the client connection once we receive the request. The next method is the send method. Some things are just like the listen method where we acted like a server trying to bind. But here, when we are trying to send commands or data, we don't use the bind option, but instead we use the connect option. Think about it like this. It is used by a client to connect to a service socket that is already bound and listening. After establishing a connection, it sends data that is stored in the self.buffer through the socket. Most of our code, we start with the try and accept block. We actively keep sending data till we have it in the buffer. And suppose if we get a keyboard interrupt, we then terminate the session. We usually work with infinite loops to receive data. It's like till we keep sending it, we will receive it on the other side. We initialize the length of the data to 1 and then the response to an empty string. So while we keep receiving the data, we have this inner loop active. We have kept the buffer size to the standard size that's we seem to be using while handling the TCP connections. Or let me rephrase it. This is the standard size that I mostly use when I am working with network connections. We keep printing the response after decoding it, and once we stop receiving the data, we exit the loop. After receiving the data, this method checks for more user input. If the user types something, it's again sent back to the server. The buffer displays a prompt and then waits for the user input. This is the cycle that repeats itself. The input is then encoded and then sent through the socket. Now, in the listen method, we try to invoke another method called the self.command, and this was to read the command input. Now, let's see how this method is implemented. So, we start with initializing a byte buffer for the command lines. And then again, typical network connection, we run an infinite loop with a try and accept block. Here in the accept block, we want to close the connection if we receive some sort of error. That is, if we get any exceptions, we kill the connection. We read the prompt received from the client and then encode it. And we keep adding the input to our buffer until we press /n or enter on our keyboard. We use this to formulate a response. And for that, we have to execute the command. To do this, we have to define another method called execute. Once we get the output from the execute method, we then send that to the client socket as a response. And this in whole will how the command execution works. Now, for the execute method, we strip any white spaces. That is, if there is no command, after we strip everything, we just return nothing. And next we go on to process the commands. And for doing that, we have to import two other libraries, Slexsh and subprocess. Slexsh is usually used for parsing strings into shell commands, and subprocess is used for executing those commands and managing the resulting processes. They are often used together when you need to parse a complex command string safely and then execute it securely as a new process. So whatever output we get from these shell command execution, we try to decode it and then the command method will get the output. If we ever run into some error while running the subprocess, we just return an exception. Now, let's see how the execution of this entire script works. For demo, I made two entities. One is called the sensitive server, and the other one is called the curious client. Mind you, the client is just curious about what the server is up to. I wanted to name it the nosy client, but for PR and marketing reasons, I have named it as the curious client. We first run the script on the server, creating an open connection where the server is acting as a listener and has invoked the command shell. Client, on the other hand, will connect to the server's open port where it can get a shell. Once it does, we can get access to the files and what they display. Usually the files on the server are much more sensitive and probably not plain text files, but for demonstration purposes, I've used those as examples. So yeah, this was a very simple implementation of netcat, and we saw how it can be made using Python. There are many additions that can be implemented using Python in this same tool. For example, you can have upload, you can add routing capabilities, you can add sniffer, you can do a lot of things basically. But for this lecture, I think this is it. I probably might cover it some other time. And as you saw in the secret file, don't forget about the apples. They do tend to keep the doctors away. Um, and this was it for today's video. I hope you had fun and also learned something. Thank you so much. I hope to see you next time.